So good day, class. So continuation of our discussion about the series convergence test. So we have this ratio test. Okay. So in this test, it involves taking the limit of the ratio of successive terms, and it is defined as the limit. Okay, L equals the limit as n approaches infinity of the absolute value a sub n plus 1 over a sub n. So the following condition. Okay, so if L is less than 1, the series converges. If L is greater than 1, the series diverges. And if L is equal to 1, the test is inconclusive. In other words, you need to try other tests. Okay, so this ratio test is useful for series involving factorials, exponentials, or expressions with rapid growth or decay. Okay, so to give an example, so we have the summation from n equals 1 up to infinity of n over 4 raised to n. Okay, so using the formula, okay, or using the formula for the limit. Okay, so we have the limit as n approaches infinity of n over 4 raised to n. Okay, so okay, get the absolute. Okay, get the absolute of this. So it is equal to n plus 1 over okay, don't forget the limit rather. So we have the limit here as n approaches infinity of n plus 1 over 4 raised to n plus 1, okay, multiplied by the reciprocal of this a sub n. Okay, so again, we have the formula a sub n plus 1 multiplied by 1 over a sub n. So this is our a sub n. Okay, and to get the a sub n plus 1, we simply replace all n by n plus 1. So that's why we arrive on this answer. Okay, so multiplied by 1 over a sub n, or the reciprocal of this a sub n. So that is 4 over n, I mean 4 raised to n over n. Okay, don't forget the absolute value. So okay, so further simplify, so we have the limit as n approaches infinity of n plus 1 over 4 raised to n times 4 raised to 1 times n here. Okay, I forgot this 4 raised to n here in the numerator. Okay, so we can cancel this out. Okay, cancel this. Okay, and further simplify, so we have the limit of as n approaches infinity of n plus 1 over 4n. Okay, the absolute value. Okay, next. Okay, so we simply get or evaluate this. Okay, so so to evaluate this, so we have infinity plus 1 over 4 raised to n, 4 raised to infinity. Okay, or maybe we can do this. Okay, let's further simplify it again. We have the limit as n approaches infinity. Okay, so we have n over 4 4 times n plus 1 over 4 times n. Okay, so we can cancel this. Okay, so we have the limit of the limit as n approaches infinity. We have 1/4 here plus 1 over 4n here. Okay, so if we're going to take the limit, okay, evaluate it. Okay, so we have 1/4 over plus 1/4 plus 1 over 4 infinity times infinity. Okay, and as by analyzing this term, okay, 1 over 4 infinity, okay, as the value gets bigger, so it approaches 0. Okay, so therefore the answer here is simply 1 over 4. So this is the limit. Okay, and since this limit, okay, is less than 1, okay, our limit is less than 1. Wait, okay, since L, which is equal to 1 over 4, and it is less than 1, okay, therefore the series converges. Okay, so that's how you get or determine if the series converges or diverges using ratio test rather. Okay, ratio test. Okay,